guys, it's Mr. Johansson here with another episode of Yo at Home. So let's just do some Snell's Law problems, just give you a little review on this stuff, and we have not had enough time to go over it that much. So let's just do some simple problems. What is the speed of light in crown glass? The index of refraction, n, equals 1.52, and we can have that value equal whatever we need it to equal. If you look in your index of index of refraction table, you'll see a variety of substances. So crown glass, 1.52. Well, the givens we have here, n equals 1.52. We know c equals 3.0 times 10 to the 8th meters per second. That's the speed of light in a vacuum. Right? That's a good number to memorize. 3.0 times 10 to the 8th meters per second. We're looking for v. What's the speed of light in any particular medium? So that's what we have, the formula. The formula is n equals c over v. Now, to make sure you're doing this right, remember, this is the fastest it can ever be. So this number is always larger than this number. The only time that might be different is if this number is the same as this number. Okay, so if this number is always larger or the same, the smallest n can ever be is 1. So you're always going to have the number greater than 1. Diamond has an index of refraction of 2.42, and I don't believe you can go above that in any normal substance. So, and that explains why diamonds are so sparkly and things like that. But n equals c over v, so we're solving for v, so we can do a simple swapping of these two. V equals c over n. Now, if that is uncomfortable to you, remember that we did that by multiplying both sides by v. It cancels out there, so vn equals c. How to get v by itself? Divide both sides by n. The n's cancels out here, so it ends up c over n. So that would be algebra the long way around, which you should always be able to do. In any case, v equals c over n. So the S and S, substitution and solution, v equals c over n. Great. Sub in 3.0 times 10 to the 8th meters per second divided by 1.52. It is that simple. So let's do it on the calculator. 3, 8 divided by 1.52. That equals, it's a big long number, so let's put it in scientific notation. That's second psi. That's second and right above the 5 key. And so the answer then is 1.97 times 10 to the 8th. Now, do we have some units? Remember, n is a unitless quantity, so we simply have these units which carry right over. And that's what we're looking for. 1.97 times 10 to the 8th meters per second. Slowed down quite a bit from your 3 times 10 to the 8th meters per second. So that is how to do that kind of problem. How about this? When light hits a diamond at an angle of 28 degrees, what is the angle of refraction? That's a straight up Snell's Law problem. So draw it first. Down here is the diamond. Right? What's the substance up here? Well, if we're not saying, you assume it's air. Index of refraction of air is 1.00. Diamond is 2.42. And we have it coming down at an angle of 28 degrees. So that is the angle of incidence. And what's going to happen to that? Well, we use the Jeep story. This tire's going fast, this tire's going slow, so we know it's going to bend toward the normal. Good. So let's set it up then. The givens. Remember the formula is n1 sine theta 1 equals n2 sine theta 2. So n1 is the incident medium. That's air. That's 1.00. The theta I, or theta 1, is 28 degrees. N2, which we also know, diamond, is 2.42. And we are looking for the theta r. The amount of refraction that we have. What's the angle of refraction we have? So the formula, the good old Snell's Law formula, n1 sine theta 1 equals n2 sine theta 2. So let's set that up. So we have solving for the sine of theta 2, and it's as simple as dividing this by n2. All right, so we rewrite S and S. We have the sine of theta 2. Now the only hard part here is remembering this is not theta 2, it's the sine of theta 2. All right, so we have to take the inverse sign to get that, and that's n1 sine of theta 1 over n2 sub in sine of theta 2 equals 1.00. That's the incident media. Remember to draw this. A drawing really will keep you from making silly mistakes. Times the sine of 28 degrees, all divided by 2.42, and then we're going to have to take the inverse sign. So let's do that. So 1 times, great. So 28. Also, make sure your calculator here is on degrees. Otherwise, that will mess you up, right? So 28, hit sine. That's the sine of 28 degrees now, divided by 2.42. All right, so let's put that into floating decimal again so we can see it. 0.193. Do you think so? No. What did we miss? It's the sine. So we have to take the inverse sign. That's just press second. Sine 11.2 degrees. Does that sound about right? Sure does to me. So theta 2 equals 11.2 degrees. Don't forget the degrees. That is an absolute unit. And we got that one down. So, the next problem. What is the critical angle in... Let's do critical angle in a diamond. All right. So, remember what's happening in a critical angle problem. And it's easier if we do it... Come on up here. I'll show you. It's easier in a critical angle problem just to conceive it mentally if we have the diamond here, the air here, and there's your normal, and we have some angle that we're hitting here, and the angle of refraction, because of this angle, is 90 degrees. So that is theta r is 90 degrees. We want to know what this angle is. What's the angle of incidence that causes an angle of refraction of 90 degrees? That is the critical angle. So this is the critical angle because it causes a refraction of 90 degrees right along that surface. Remember, if we have any larger angle than that, we have total internal reflection and all the light will stay inside there. Again, that's why a diamond is so sparkly, because it has the lowest of all the angles of this critical angle. So how would we calculate that? Well, let's see what the givens are. Okay, we have our angle of incidence is the unknown. So theta I is what we are missing. N1, the incident medium, that equals 2.42. Theta R equals 90 degrees, and N2 equals 1.00, because it's air. And so look at the formula. N1 sine theta 1 equals N2 sine theta 2. Solve this for this thing right here by just dividing N2 sine theta 2 by N1. All right, now the S and S almost gets amusing to see what happens to this. All right, so N2 sine theta 2 over N1 equals the sine theta initial. Well, N2 is air, so that's 1.00. Well, the sine of theta 2, sine of 90 degrees. Do you remember that? 90 degrees sine, that's 1. So 1 times 1 over N1. N1 is 2.42. That is the refractive index of the incident media, in this case the diamond. So we basically are taking the reciprocal of 2.42. So you can really just enter 2.42, hit the 1 over x key. Now you have a rather small number, but you know that's the sine of the angle you're looking for, so press second. sine. Well, look at that. You have 24.4 degrees. And that, my friends, is the critical angle in a diamond, at least in a diamond to an air interface. If you have some other substance here, well, you would use the different refractive index that would be for N2. But if it's just air, could not be easier. Thank you very much. Those are some example problems from our Snell's Law stuff. See you next time.